Comparators. A comparator is a circuit which compares a signal voltage applied at one input of an operational amplifier with the known reference voltage at the other output. It is basically an open loop operational amplifier with output plus or minus V saturation, which is almost equal to VCC, as shown in the ideal transfer characteristics. However, a commercial operational amplifier has the transfer characteristics like this. There are basically two types of comparators, namely non-inverting comparator and inverting comparator. The circuit of a non-inverting comparator is shown as this. A fixed reference voltage Vref is applied to inverting input, whereas a time varying signal Vi, which is the input signal, is applied to the plus or non-inverting input. The output voltage is at minus Vsat for Vi less than V reference, and V naught output voltage goes to plus Vsat for Vi greater than V reference. The output waveform for a sinusoidal input signal applied to the plus input for positive and negative V reference respectively is like this. So positive V reference, how the voltage will be, and negative V reference, the voltage variation is going to be like this. So the voltage reaches minus Vsat to plus Vsat. Next figure shows a practical inverting comparator in which the reference voltage V reference is applied to the plus input and Vi actual input is applied to the inverting input or negative input. So this is a practical inverting comparator. For a sinusoidal input signal, the output waveform is shown for V reference positive and negative respectively. Next we will see briefly about clippers and clampers. Clippers, first we shall see clipper. In certain applications, a part of the input waveform has to be limited or has to be removed for some signal processing applications. So the circuit that removes a part of the input signal is called a clipper circuit. The wave shaping circuits such as those used on digital computers and computer applications mainly perform voltage limiting, voltage clipping and voltage clamping functions. A clipper, also called an amplitude limiter, consisting of an inverting amplifier circuit with a back-to-back Zener diode and a single diode connected in the feedback loop. Following figure shows a single polarity clipper circuit constructed using operational amplifier. The gain of the circuit is determined by the ratio of resistors Rf by R1. A signal to be clipped is applied to the inverting input of the operational amplifier. So here you can see this is the input signal and this is the clipping level. That is when the positive half cycle, when the input voltage reaches 4 volt, that is the clipping level. So at that 4 volt, the signal will be clipped. But negative half cycle, no change. Right? So it is a clipped output. Since the clipping takes place at the positive half cycle, it is called a positive clipper. So this is the circuit of a negative clipper. Here the clipping takes place at the negative half cycle. A clipper that clips or limits amplitude in both directions. Sometimes you may have to clip in both directions. Can be achieved by connecting two Zener diodes back to back, as shown in figure. The clipping voltage level of the circuit is the sum of the forward bias voltage of one Zener diode and the avalanche voltage of the second Zener diode. So here you can see the clipping takes place at positive half cycle as well as in the negative half cycle. At both the half cycles, the clipping takes place. Next we have clampers. Clamper means it is also known as level shifter. So sometimes you may have to raise the level of the input signal either upper or lower. Either you may rise or you may lower the level of the input signal. So that level shifter circuit is called a clamper. A clamper circuit is to add a fixed voltage level to the minimum or maximum value of an input signal. The output is clamped to the desired level by either shifting up or shifting down an input signal, depending on whether a positive or negative clamping action is required. So this is the circuit diagram of a positive clamping circuit. So this is the input waveform. Output waveform is shifted up. The input signal VI is applied at the negative input terminal through a capacitor C. During the negative half cycle of transition of the input voltage, the output of op amp becomes positive. The diode D1 connected at the output of op amp is forward biased, and this causes the capacitor to get charged. The charging continues until the inverting input terminal of the op amp attains virtual ground condition. At that instant, the peak voltage VC across the capacitor becomes equal to the negative peak of the input signal VNP. That is VC equal to VNP, where VNP is the negative peak amplitude of input signal. When the input voltage goes positive, diode D1 becomes reverse biased. The capacitor retains the previous voltage VC. The output voltage V0 is then given by V0 equal to VI, input voltage plus capacitor voltage VC. So V0 equal to VI plus VNP. The voltage VI is shifted by the voltage across capacitor. So this is the circuit diagram of negative clamping circuit. Okay, so either you can clamp positively or you can clamp negatively. Negative clamping circuit using minus V reference. Thank you.